Hello everyone. Very good morning. Let me share my screen. Just quick confirmation. Am I audible and is my screen visible? I'm on a Dureka page. Good morning, Dinanath. Yes, I can see your screen. Yes, thank you. Hey Sachin, how are you? Thank you. Thank you for the confirmation. Let me get a cup of tea, okay? I'll be back in 2 minutes. Okay. Uh, okay, people are joining in. Meanwhile, let me do the spit test. So guys, I hope I'm audible and visible to everyone. The screen is also visible. I got a couple of confirmation already. Um, so hopefully it is the same for all. So meanwhile, okay, it's good. So in the last session we had discussed about networking. That is what we are going to start in this particular session. And for that, I wanted you to guys to go through this one, basics of networking, because again, networking itself is a very vast topic. So I wanted you guys to, take a look at basics of networking so that we can focus on networking in GCP, right? So that how all those concepts of networking are integrated or implemented within Google Cloud Platform. That will be the agenda. Uh, so that's where I created this one with some basic or fundamentals of the networking concepts, right? I hope you have gone through this. If not, take 1 or 2 minutes. But I'm not sure. I'll not be able to go through all the details from scratch, right? So that will be in a new session in itself. So okay, so let's give 2 minutes of time. Um, how many people we have? We have half of the batch right now. Okay, let's wait for 2 more minutes. And I also uploaded the rough of the previous session already on that day itself, on Sunday, last Sunday. But yeah, so meanwhile, I'm not going to take you through the basics, but meanwhile, we have 2 minutes. So let's take a look of basics, what I meant by basics. So in the basics, I just wanted you to take a look at OSI model. Just a brief. We don't need to go in deep how it works and all. There are different layers of OSI model of any network, right? And then what is protocol, right? What is port? Okay, what is IP address? What is MAC address? What is RFC 1918 address space? This is important. What is firewall rules? Okay, this much information is enough. Okay, then rest of the things I am taking care. But these are very basics. You might have heard all about. I mean, about these concepts in your maybe in your engineering or in your if you're working from networking perspective, then you already might be knowing. But I just wanted you to go through the basics once so that I can directly start with those concepts and from the GCP perspective, right? So let me jump on to any questions on any previous sessions assignments, guys. So good morning, Samsher. Is there any specific book or PDF on Google Cloud Platform that you can suggest for reading? Okay. So I can let me recall. I have not used any book so far, but I keep on following people on maybe like YouTube channels or their their websites, their blogs, like that. And those are some of them are Google employees, and some of them are very good YouTubers on the tech sites, right? So that's what I follow. But from the book or the PDF perspective, let me check that, and if I get something, maybe if I get a PDF, I'll share with you guys. Okay. Okay, so let me set this up, the question box for me. Sorry, guys, give me a minute. This question box, it's not shrinking. Okay. Okay. Okay, so let's start then in the networking. So a couple of things I wanted to set the expectations about networking was one of the thing we already discussed about the basics, right? So you are supposed to know the basics of networking, right? The topics that I just mentioned, that is okay. Other than that, again, there will be slight differences how the cloud providers are implementing these networking concepts in their respective clouds, right? Let's say AWS has another way of implementing the networking concepts. Azure might have AWS might have differently, and Azure might have been doing differently. GCP might have been doing differently, right? So this particular session will be focusing on GCP. Okay, so let's not digress and compare every now and then how it is being done in other clouds. Okay, my focus will be completely on Google Cloud implementation of networking. So there will be a couple of differences. If you are coming from other background, you might feel that way, right? So it is okay to put a question or something like that, your thought or something, that is okay, but we are not going to digress and discuss about the other cloud providers and how that networking and all those concepts from the other cloud provider perspective, because this is GCP implementation of the networking, right? So that is one more point I wanted to clarify, okay, before we jump in into the topics. Okay, so now the first question why you should be asking, what should be asking is why networking, right? So what do we get when we say we have all these concepts, right? The private networks, VPCs, subnets, firewall rules, IP addresses. What are all these? Why do we need all these networking, right? So what networking gives you is what are the three. I think there will be three major advantages of working in networking. I mean, the implementation of networking, right? So those will be availability, latency, and security. Okay, these are the three main advantages using of using the networking concepts in your any infrastructure, be it on premise or cloud, doesn't matter. Networking is it's a global concept that you need to have, right? So what do I mean by availability and latency? We are going to see with a use case. I'm going to show you a real use case, how it is being implemented, and security, right? So availability and latency we are going to cover in regions, zones, and something called as edge locations. Okay, then security, we are going to cover something called as VPC, VPN, subnets, all these topics we are going to cover. So using all these concepts of networking, we are going to achieve all these advantages, right? So now uh, let's take a use case. Okay, so that way it will be little more understandable that how the availability, we are going to talk about availability and latency. Okay, so just imagine that you have an infrastructure. Okay, then you have a VM in that. Okay, let's say, or instead of an infrastructure, let me call it as a data center, right? First let's call it as a data center. So this is a data center. Maybe we can say it is in Mumbai. Okay, and then it has a rack, or it has a something called as, I just put it as a name X. What is it? I'll tell you. But there is a rack, and inside that rack you got one VM created. Okay, you have a VM here. Now on that VM you hosted one website, xyz.com, let's say. Okay, okay, and now people are using it. Maybe it's a some e-commerce website or any thing like that, and people are doing some shopping or stuff like that, online shopping and all. Okay, so there are some customer base who are using this particular website. Okay, now what happens is, let's say there is a sudden spike. Okay, suddenly the customers increased for your website. Okay, they are trying to hit. What will happen is, there will be a latency issue. Okay, there will be a latency issue because there are so many people, and this particular website is not able to, this particular website is getting served from only one VM, right? So this website or this VM will not be able to serve those many requests because it is beyond its own capacity, correct? So that will cause you a latency issue, right? And let's say there is something broken on this VM, or maybe you want to do some, it's not just about GCP I'm talking about right now, but in general case, or it's in maybe in your on-premise, you're doing some patching, you need a restart, or in even in cloud you need some other activity where, or you need to you are doing a patch on your website itself and you want to restart the web server. You somehow, if you want this VM to restart, right? So there is no availability, right? There is no other VM which can serve this particular traffic, right? You know what I'm getting to, right? So these are the two issues that generally we face. Okay, latency and availability. How can you solve this problem? You can create one more, either on the same, but you can also create it on another zone. Okay, so you can create another VM, and these both can serve this particular. Okay, so if I can take this one, so these both now can serve this particular website. So even if, so what are we doing here is, oh, sorry. Okay, so what did we do here when I did X? This X is nothing but called as zone. I told, right, within a data center we have multiple racks. Okay, multiple racks. This is another rack, this is another rack. So these are called as zones. This is zone hyphen A and this is zone hyphen B. Similarly, there will be another zone, zone hyphen C. Most of the data centers will have 3 zones. Okay, so what are we achieving? If we create another VM in another zone, what are we achieving? We are achieving a little bit of availability, because if this VM1 goes down, the VM2 can still serve the traffic. VM2 can still serve the traffic for this particular website, right? That's how availability can be partially solved. But the latency, right? The latency depends on two things. It depends on the number of users, also the region, or not region, the location, I should say, location of the user. So if this guy is in India and this guy is in US, this guy is in Europe, right? So these two guys will face a little bit of more latency than the Indian guys or the Indian customers, right? So Indian customers will feel that the website is working fine, whereas the US and Europe customers may feel a lag in the responses, right? Why? Because it is getting, the traffic is getting served from a data center, and where the VMs are located, it's in Asia region or in India region, right? That's where the latency still remains. Now to solve this particular problem, what we can do, we can go to another data center, right? This is DC of, let's say, London. Okay, there is also a zone on this, and I can create another VM3, or maybe itself the VM2 I can create here. That way it will be latency issue. So now what happens is, this particular xyz.com website, now now the same website, you can put certain thing. Okay, we'll discuss this. This is LB, this is load balancer. What we can do is, we can put all these VMs, VM1, VM2 and VM3 under load balancer, and from load balancer it will show me the website. So what will happen is, depending upon your region of your customer, this is Europe, this is US, and this is India, let's say, right? Asia or India. So depending upon the location of the user, this particular load balancer will send the traffic to the respective, the nearest resource that can serve this particular traffic for your website. So if the request is coming from Europe region, automatically this load balancer will send the request to VM from the Europe region. If you don't have, and for US, let's say we don't have, right? So Europe, I mean US traffic will go either to this and that randomly, right? That is also load balancer can do, and depend, I mean, that random pattern may depend upon the utilization of the resources, if this is more utilized and some stuff like that, right? So depending upon different matrices, load balancer will redirect to that particular resource, a respective resource, right? So with this thing, what we are trying to achieve is these two problems, that availability and latency. So the more expansion you do, if you create a data center in Iowa, then you can create a VM here as well, and you can put that under the same load balancer, and now this US guy will also feel a better response, because it will be served from this particular data center, right? So this is about the latency and availability, and why it is important from networking perspective is the point that I'm talking about, this zone. right? Where we are actually replicating the resources in different zones or regions. Regions means data center. I mean, London is one region, and under that region we have zones. Zones are nothing but, let's say, you can say like a physical data center is a physical building. Under that premises you have multiple buildings, right? And those, each building is again one zone. Okay, so now if you this is all about the regions and zones. So the topic I wanted to come to was regions, zones. Give me 1 minute. Regions, zones, and edge locations. Okay, now let's see that from regions, zones. Let me check that. Yeah, maybe this one. Okay, so if you go to this particular URL, right? This is the cloud.google.com itself, their documentation. So it says 35 regions they have, 103 zones they have, and they have 173 edge locations covering more than 200 countries and territories in the world, right? And they also say some coming soon, regions where they are deploying their infrastructure right now, right? So that is still in progress, kind of. But meanwhile, our statistics I am interested is in 35 regions, and these keep on growing as you see here, right? So what happens is, if you scroll down a little bit, right, you can see current regions with 3 zones. So if you see here, I'm not sure whether you are able to see it. Yeah, so in India there are 2 regions, Delhi region and Mumbai region. Similarly, Hong Kong, Taiwan, Tokyo, right, Sydney, Melbourne, you can see so many other regions as well. I mean, covering all those major geographical regions in US and Europe as well. Okay, and exception, there are some exceptions where the regions are has 4 zones. So what I mean by that is, basically we have region is like location of the data center. Okay, region is nothing but a location, a geographical location, I would say, of a data center. Okay, and then zone, what is zone? Zone is region is subdivided into zone. Okay, zone is nothing but actual deployment area. Okay, so as you see right here, this entire is nothing but a data center. Under that you have another rack, right, where your VM is actually getting deployed, right? So that particular rack or that particular premise within the data center is nothing but a zone. Generally, every data center will have 3 zones per region. Majority of them will have 3 zones per region with some exception. Okay, what do you mean by exception? I mean, some of the regions, okay, out of those 35 which I showed you on the website, right, out of those 35 regions, some of the regions are such a way that their resources or their existing zones are already occupied. That's why they have created one more zone in the same region, right? So they might have 4. So like one of the example is US Central 1. Okay, example US Central 1. This has 4 zones. Okay, so it will be zone hyphen A hyphen B hyphen C and hyphen I think F. Okay, I mean, the naming doesn't, nomenclature doesn't matter, just it is the Google way how it is nomenclated. Okay, so region can be like Mumbai, Delhi, right? London, example. But these are example, but we do not call by the city names for the regions. We call it as Asia South 1, Asia South 2, like that, Europe Central 1, like that. Okay, so that will be the nomenclature that we will be using, and under that zones it will be like Asia hyphen South 1, sorry, South 1 hyphen A, then this same thing hyphen B, right? These are the zones that we are discussing under the Mumbai data center, let's say, right? So it will be hyphen A, hyphen B, hyphen C. Similarly, for US Central 1 region, it will be US Central 1A, US Central 1B, US Central 1C, and US Central 1F, the fourth one, right? Then what is edge location now, right? We discussed about the zones and regions already, but what is edge location? Edge location is also called as point of presence. Okay, which means Google Cloud networking is in place at this location, but resources cannot be deployed at this location. What do I mean by that is, let me see if I can show you. Not here. Let's say, let's search edge locations GCP. Uh, so there is one similar website that we have seen, I mean, similar web page that we have seen for regions and zones, right? Similarly, we can see the, not this one, but we can see the edge locations on the, a graphical or a global view. So but essentially what I mean by that is, let's say Mumbai is Mumbai and Delhi, right? We've seen this, these are the regions available. We have seen already, right? But Chennai, right, is not a region, but it is one of the edge location. So so what happens is, let's say uh, these edge locations are also called as point of presence, as I said, right? These locations where the networking is present. The Google Cloud has the networking, their private fiber networking is already in place for these locations, and that is where from there they can route the traffic. So let's say there are users near Chennai, okay, example, and they are trying to serve something, maybe YouTube or any other, let's say YouTube, right? So these edge locations work as a point of presence for the nearest traffic to serve, right? So if any traffic coming nearby Chennai, it will be used, I mean, it will be served from these edge locations. These edge locations has feature of cache. Everyone knows cache, that the contents are cached at that particular location, and then it will be uh, uh, you know presented, or it will be served to that particular nearest user base, right? But you cannot create Google Cloud resources like VM or anything at this particular I mean at this particular location, because it's not a region, it's just the edge location. Okay, so the main point here to catch is the cache. Okay, just keep this in mind, this will come later. So some of the resources are created at global level, some of them are at regional level, and some of them are zonal level. We are going to see whenever we are going to create understand different components now in networking, we are going to see whether it's a global, whether it's a regional. We have seen, right? So VM is nothing but a zonal, because example, VM is zonal because we create a zone. Zone is must for creating a VM. So VM is a zonal resource. Similarly, we are going to create VPC. VPC is going to be a global resource. We are going to create subnets. Subnet is going to be a regional resource. Okay, we have to select a region that is a mandatory for creating a subnet, let's say, right? So that is like a regional. Some of the resources are optional. You can create global as well, or you can create regional as well. Okay, so depending upon what you choose, the visibility of that particular resource will be at that particular level. So if you choose to have it only visible to a region, then it will be only, it will not be replicated. Okay, so but yeah, I mean, when we'll go there, we'll see. Okay, so now the next concept, this is all about the introduction about regions, zones, and edge locations. Any doubt over here? What data do we cache at the edge location? So data depends upon what is the, I mean, this is, so again, as this is not just being used by Google Cloud, but it is also being used by Google Workspaces. So what do you mean by Google Workspace or Google Suite, right? So there are Google products, you know, right? You must be using Gmail, you must be using Google Drive, you must be using your YouTube, right? So all these Google products that you are using, that is the contents of those are also cached at these edge locations. Edge locations, this is an entire infrastructure of Google that we are using. I told you, right, in the introduction, that we are Google and us as a public public cloud vendors from who are using, customers who are using the public cloud of Google, they share the same infrastructure that they have for their products, right? So the caching happens for all of such things. So if I have a website, it will also have some cache contents at that particular edge location. So if anyone is if the traffic is coming from Chennai to my website, if it is hosted on Google Cloud, that will also can be served from that cached location. If he is looking for a cache, I mean, if that can be, now if you understand what is how the cache works, if that can be served from a cache location, then it will be served. If I have a static website, right, and it doesn't change, so it can be served from my cached location, right? So that's how the edge locations will help you to reduce the latency. So the point we wanted to discuss about latency and availability is again the edge location. Edge location helps you reduce the latency at a greater level. Okay. Can you also cover how China is different, if GCP can be used if customer also from China? I think China, okay, let me, I'm not, researched on the China location, Dia, but I'll just check. That's a good point. I'll just check on that particular point, how it is being served, and we'll come to that. Yes, I know China has Alibaba Cloud Shrey, but we are talking about the GCP, right? So if they are they allowed to use GCP, and how do they do if they want to avail the GCP features and all those things? Is it even possible? So that's what I wanted to check. But I know, yeah, they have Alibaba Cloud. Okay. So was it cache? Cache is again one. It's again basic. Okay. So cache is just storing your static contents at particular location, so that you don't have to hit your website again and again, or your backend server again and again. That's simply a cache. So whenever I hit a particular YouTube website, it doesn't always show me the contents from the youtube.com. It might be cached at some middle place, and then it will be showed. That cache can be at your browser, cache can be on the server side, cache can be at different places. So that's basic of networking again. Okay, so let's not go into cache a lot. I mean, there are a lot of questions coming in, but let's park it there. Okay, it's not that really important. Whenever the topic will come, otherwise the main topics will go, and then you'll have to stretch. I'm okay stretching beyond 10, but that was just a point. Okay, that you get an advantage of caching by edge location. Okay. So caching for Gmail and all these things, Shrey, sorry, let's not digress. Okay. So now coming back to the topic, what is VPC? So VPC is virtual private cloud. So it is by the name as it says, right? It's a private cloud, but it gives you the feeling of private cloud. What do you get by the private cloud? You get isolation, you get more security, right? Because you have some premise like a facility or feature that you get with the private cloud, right? So that is nothing but the advantages of having a private cloud. But since it's like creating security, I said, right? Isolation, like a perimeter or a boundary, right? Then secured, of course. And why we say it is virtual, we cannot really see it, right? That's why it is called as virtual. But by the terminology, virtual private cloud is like creating your private cloud on the public cloud space. In this case, the GCP. So that's the simple definition of VPC. Okay. So what are the advantages that you get when you have a VPC in place? Okay. So VPC is like creating, as I said, creating perimeter. So this is very important. This is very basic to understand what are the advantage that we get. So just with a simple example, if I have a, okay, let's say you want to go and book a flat in some apartments, right? So, and security is your one of the main aspect, right? Security, as I said, right? In the very beginning, security is one important aspect that everybody should look for, right? So if you're looking from a security perspective, right, and if you're opting to buy a flat in apartment, or that's what we call society also, right? So what do we see? I mean, this is very layman understanding of VPC, but it is very relevant as per my understanding. So what we see some society with a boundary, that they have a compound wall, they have certain walls around the area. Those can make it secure. Than this is a, let's say we call it as, let's say this is a road. Okay, this is a public road, right? But we can make our premise secured with these walls, right? So creating a perimeter, this is nothing but your VPC. So what are we doing? We are basically securing our land by creating a perimeter around it, right? This perimeter is nothing but your VPC. Even though you are living in a city, right, and there are a lot of apartments in the city, right, but they all have their own boundary towards it, right, around it. So that boundary is nothing but VPC, right? Now under that, you can have maybe what you look for is some common area, right? Some community hall or lawn, or hall for functions, right? And then you have certain towers. Let's say, let me put it this way. Okay, and then you have, let's say, like this. Okay, so these are independent row houses. Okay, that's how a typical apartment, Indian apartment looks like. So if you're coming from a different geographical location, that might be a little different in your case, but this is our I mean, simple terms, Indian apartments are structured. So we have some common area, let's say. Then we have this is, let's say, tower. This is tower A. This is tower B. This is tower C. Okay, and this is let me say uh, row house, row house 1, and this is our row house 2. Okay, so now what happens is, in tower A there are all 1 BHKs. So 1 bedroom, hall and kitchen. Okay, so these are small flats. It has only one bedroom, 1 hall and 1 kitchen. Okay, then this one is little bigger. So this has all 2 BHK. So there are 2 bedrooms, and let's say this is even bigger. It has only 4 of them, and it is 3 BHK. Okay, just for the simplicity, I'm just telling you. Okay, this might be a mixed one and everything, that is okay, but just I'm trying to relate your concepts with a simple example that you might be able to understand very easily. So VPC is nothing but this particular boundary. Okay, so whoever needs to enter, okay, so let me put it in some other color. Whoever wants to enter in this particular premise needs some authority. Okay, there will be a security guard here. That security guard will help you decide whether he should be entering, whether he should be allowed or he should not be allowed. This particular security guard is nothing but your firewall. Simple. Okay, so firewall decides who enters, who does not enter. Then you have these these are internal paths are also there, right? These are where you can walk right around the society. Then all of them are connected, right? These are called as routes. Okay, these routes can be virtual also. Let's say if you know something about intercom facility, that this flat, I mean, this particular flat owner can talk to this flat owner directly, right, on the private line without using any cellular network or any leased line. He can directly talk by just dialing the number of this particular flat number, right? So that is called as intercom. This is also you can consider as a route. Okay, we are going to see what is route and all, but this is also route. Now within this particular VPC you have a different dimension wise there are different sub buildings, right? This is a bigger one, this has a bigger this has a bigger one, this has this is even bigger but it has a smaller units, right? And this is small but this is a one single unit, it's a big duplex house kind of, right? So these things are called as subnets. Okay, within a subnet you have some subnet has some area, square meter or whatever, right? Then you have different options, right? You can choose 1 BHK from here, or you can choose 2 BHK from here, you can choose 3 BHK. So depending upon how big resource you want, you can select from a different subnet or uh, you know different, basically different subnet, right? So with this particular example I just wanted to relate the networking concepts with the simple day-to-day life understanding. Hope this is clear. So VPC, by creating a VPC, we are going to get some security. So even though in a normal case, let's say if I draw this way, right? You have this is GCP. Within that, you have a project. You might ask, I have a project, and there is another project. Okay. These projects can, by default, anyways, they cannot talk to each other. Then why do we need to secure it, right? So let's, it might happen that within a project you have multiple teams also, right? And you don't want this team to access these teams' resources, right? So that way you can create a VPC, multiple VPC, and then they will not be able to communicate with each other unless you allow it. There are other mechanisms to create a association between VPCs that we are going to see other later. But essentially the VPC is basically creating a different perimeter around something, around your resources, right? By default there will be default there will be one VPC which will always be created whenever you create a project. A default VPC will be created automatically. Okay. But you can create multiple VPCs also within the same project. And now within let's say within the same project, if you are working for the same organization, you have different projects. One project is for some other purpose, this project is for some other purpose, some other application. They want to talk to each other, right? They are sitting in different VPC, right? This is in another VPC, this is in another VPC. They can also talk to each other if we want to. We have to configure something which we are going to cover, but they can also talk to each other. But unless you do that setting, these are some isolation and the secured perimeter or the boundary around your resources that you get, right? That's how it is. So even though you have given the permissions from project 1 to access the resources on the project 2, unless and until it satisfies the requirement of that particular VPC, it will not be able to communicate. As I said again, right? In this particular example, just remember this. Okay, we are going to cover this particular intercom. This is not your public number, right? This is not the public number that you dial, right? This is not your mobile or a landline number that you dial. You dialing the number of that particular flat, right? If this is 301, I just dial 301 and it connects to 301. That means it is using some private number, right? Private number means just relate that with the private IP. And public number, this is also called as external IP, right? Just keep these in mind, and whenever we are going to see any particular this topic individually, we are going to visit this particular diagram. Okay, I hope this is making sense. So let's see what is VPC now, right? So VPC, I explained you here that we are going to get a perimeter around our resources, and under that particular perimeter we are going to create our resources. Now we cannot create VPC is, let's say, okay, VPC is global, okay, does not have IP address. So since we do not have any IP address, we cannot create any resources directly under the VPC, right? Cannot create resource directly under VPC. What do I mean directly? We still have that VPC as a boundary, but we do not create the resources under VPC. We need something called as subnet. Okay, it is nothing but a subset of your network. When I say network, now it is going forward, it is VPC I'm talking about, right? So it is a subset of your network, or subset of your VPC is nothing but subnet. Subnet gets a, it's basically a regional resource, right? And it gets an address space. Okay, we'll see what is address space as well. Okay, So, but as I shown you here, right? You need a certain square feet or square meter area to put this particular building, tower A, right? Then tower B has a certain other uh, spacing, right? Or the dimensions. The tower C is having a different dimensions, right? That is nothing but what I'm referring as address space. So depending upon the address space that you depending upon your address space, we can calculate how many IP addresses we can generate. Okay, what do I mean by this point is address space is nothing but a group of it's a group of IP addresses. Now IP addresses you already might be aware about, right? So it's a basic. So you have some 10 dot 120 dot 10 dot 10. So that's one IP address. Now similarly the same IP address, but at the last it instead of 10 it will be 11. That is another IP address. So IP address is basically a location or a unique way of identifying a resource. So address space on the other side is nothing but a group of IP addresses. Okay, so just like this one, that you have multiple flats in this particular tower, this entire tower is nothing but a group of these particular smaller dimensions, right? Similarly, address space is nothing but a group of IP addresses, and IP address is a single unique identity for a particular resource. I hope that point is clear now, right? So that's all about the subnet. So subnet will have an address space. So now let's jump on to the uh, let's say, before that I wanted to cover one more thing. Now just let's finish the types on the theory part, and then we'll jump on to the console after the break, and then it will be easy for understanding whatever we learned so far. So now the VPCs, as I said here, right? By default, whenever I create any project, automatically a default VPC will be created. A default VPC will be created, I said, right? But I mean, there are some characteristics of default VPC. If you do not want to use the default VPC, you can choose a custom VPC also, or you can also choose to create an auto VPC. So there are total three types. Okay, default VPC, auto VPC, and custom VPC. We'll see the characteristics better. I'll create a table. That way it will be better to understand the correlation or the differentiation. So first of all is the default, another one is the auto. I'm sorry, auto, and this one is custom. What I wanted to do, I wanted to center this. Fine. Not sure where is it. Why? Fine. No issues. Okay, it will be here. Okay. Fine. So every project, as I said, every project will get it by default. Okay. This is very similar to default. Okay. But you can create it by own. Okay. Whenever you select that I want to create auto VPC, that means you are opting for a new VPC, right? It will not come by default at the project creation level, right? And you can create many. You can create multiple auto VPC, but the default VPC only will be one that will be created by your GCP for your project, right? This is again you have to create it. Okay, when you create a auto VPC, it will be very similar to default in the characteristics, but if you, I mean, this is needed when you want similar to default, you want an additional one similar to default, then you can go for the auto one. Now what happens is it creates one subnet per region. As I said, right, subnet is a regional resource. I mean, don't relate this particular example by geography. Okay, so VPC can be global. Okay, so VPC can be global. Now don't relate as it is with the apartment or with the GCP concepts, right? Because VPC is global. VPC, this parameter can be global. It can be for all the resources. If one resource is in London, one resource is in Mumbai, you can have them in under the same VPC, under the same boundary. Okay, so don't relate with exactly with this particular physical example of the building. Okay, because building will typically be in a region, right? So don't relate in that perspective, just to be clear. But VPC is a global resource, and under that you have a subnet, right? This is nothing but a subnet. This subnet is regional, so this will be in Mumbai, this will be in London, this will be in, let's say, in other region, right? So what this particular default VPC does is it automatically creates one particular subnet per region. So we have seen 35 regions on the website, right? So there will be 35 subnets. It will create 35 subnets, and each of them will be for one region. Okay, this will also be same as default. So this will also create the 35 subnets, one for each region in auto mode. You have to create it again, so you get a lot of customization for the custom VPC. You have to create, you can only create, you can create whenever you want. So let's say you opting to, let's say you have a website which is only you want for to serve only India, right? Then that particular website will, you can host it directly just for any region, one of the region, let's say in India, and that will be, that's it, right? In Mumbai, let's say you select. So you don't want why do you want to create 34 more other subnets? Because you are not going to use it, right? So you're not going to create that, right? So depending upon the IP addresses that you have for your organization, right? You can just choose to create one or more subnets. At the same time, you can also create more than one subnets in the same region. So let's say for a same Mumbai region, you can create one more subnet in the same. But in default, since you don't have control and Google has already given you that particular one subnet, so if it is exhausted, if that particular address space, the group of IP addresses that you have, let's say you have 10,000 IP addresses, right? And those all are being given to some resources. Then you don't have any options in case of default. That's where custom will come in picture, right? So that is one thing. Just hear me out on this, okay? I mean, whenever we are going to see this in demo or in the walkthrough, that time it will be for sure, it will be clear. We'll see those things there. So now by default, we also get 4 firewall rules. Okay, there are some firewall rules which are pre-created or pre-populated. Those are automatically embedded in your VPC, default VPC. Okay, then those are not pre-populated in case of, not pre-populated in case of auto, but you can select them. Okay, similar is the case, not pre-populated, automatically you won't get any firewall rules here. But you can create and select them. Here also you can create and select them. Okay, so that's for the firewall rules. Then you have something called a CIDR range. So /20 CIDR range by default for each subnet. Same is the case here also. So I'll write same as default, and you can choose the CIDR range. Okay, we'll see what is CIDR range just in a just on the high level. CIDR range is nothing but your address space, but I'll show you how it looks like. Okay, uh, routes are by default again same as default, same as default. Okay, so routes wise everything will be automatically created by GCP on your behalf, right? Now here you can expand the subnet to /16. Here also you can expand to /16. Okay, and you can expand to any size. Okay, now we'll see this point also. I'm just taking a theory, but we are going to see the practical also, so don't worry. Okay, so what happens is let's say any size, maybe I can say as per RFC 1918 address space. Okay, so what happens is how the address space looks like, right? So as we have seen, right, we have let me take another. So we have VMs. So this is a region, and for this region we created a subnet. So this is the subnet now. So let's call it as a subnet 1. Okay, subnet 1. And while creating a subnet we'll have to select a region. So let's say we created for US Central 1 region. Okay, so this particular uh, region has a subnet called as US Central 1. Okay, and the resources that we are creating under this, okay, those will be all US Central 1 region resources, right? Similarly, I mean, this is a bigger picture. If you see, there can be another subnet. Okay, but we are just talking about one subnet over here. This can be a Mumbai location, and you can have resources here. Doesn't mean that they cannot talk to each other, because they are in the same subnet. Even though they are in different subnet, they are in the same VPC, right? They are in the same VPC. See, VPC is again a parent to subnet, right? So as long as they are in the same VPC, they can talk to each other. Okay, so this particular VM has an IP address. So let's say IP1, this has an IP2, this has IP3, right? So what happens is this particular collection is nothing but address space. Okay, this is also called as CIDR range. Okay, these are called as CIDR range. This is the basic of networking. It's covered in that particular PDF which I gave you, right? CIDR range and address space is nothing but the same. Now if you want to, let's say, this particular thing, right? Let's say 128.0.1, 128.0.2, 10.128.0.3. If I need to group them, how do I say? I can say 128.0 dot star, right? Right? So instead of star, I can say 0. In networking, I say 0 and slash something. This X can change. This gives you, this X means, this X decides how many of the IP addresses can be generated from this. Even though if I say this dot 0 and then I say 20, right? If I show you what is /20 stands for, so there is a website, okay? I think Cider XYZ. Okay, so there is a website cider.xyz, just very short URL, you can search it. And if you see here, right, I want 128, I want 0, and I have 0, and I have 20, let's say, right? So if you can see here, I can create 4096 IP addresses. Okay, so these IP addresses will look like 10.128.0.1, then 10.128.0.2, 10.128.0.3, like that, right? Then once it is 255, then it will be 1.0, 1.1, like that. Similarly, I can create 4096 if I keep the cider range as 20. If I keep 16, it increased to 65,000, from 4,000 to 65,000. So what do I mean? What I wanted to show you is the /20. /20 is small, /16 is bigger, /8 is even bigger. Okay, /32 is the smallest. So if you want only one IP address, okay, so let's say you want 10.128.10.155, let's say, right? So you can say either you can put it like there, or you can put /32. /32 means this will be the only IP address in this particular address space. Okay, I hope this particular point is now clear. So what is RFC 1918? That's basically an global IP authority. It's a very, I mean, it's a global concept, not just for good GCP. Okay, it's a IP authority that they have selected, and they have given you particular address spaces to be used for your communications. You can't use keep on putting any random numbers. They have given some ranges. You can only use those ranges in your projects. Okay, that's a basic concept. Even, I mean, none of the cloud providers will be allowing you to create the resources other than that particular range that has been decided by that authority, and that's a globally for the entire world to be followed. That's like a global rule, you can say. Okay, so after the break we will see the all these things on the console, but let me just check the questions. One second. Subnets would typically group VM for teams certain configurations. No, subnet is not a group of VM. Subnet can be, just understand this. Subnet is a a group of all the resources. Now, in case of simple example, I'm giving you just for VM, but you can create you can create other things as well, right? IP address is not just for the VM, right? You just call it as a resource. So it's a group of resources having the similar IP addresses, and those IP addresses will be grouped and will be denoted by whatever the subnet range, cider range, subnet range, all will be the same nomenclature. I mean, we can interchange these nomenclatures when we work, but subnet range or cider range will decide your resource IP address, right, not the type of your resource. So don't directly group the VMs together for certain teams or certain configurations, not configurations, but yes, for teams you can say yes. How do we decide how many subnets our project needs? How many VPNs? VPNs, don't confuse VPN here. Okay, VPN is another concept which we are going to see later, Dia. So just hold on for VPNs. But how do we decide the subnets? So depending upon how many resources you might require, right? So I can't tell you the hard rule that these many resources, these many subnets would be needed. It depends upon how many resources you need, right? So let's say you have now you are working as an architect, right? And for your project you want to migrate, let's say 50 TB of data into GCP. And for that, for bringing 50 TB of your data from on premise to your GCP, okay, you need to decide what are the resources that I'm going to do. So let's say on premise is a Hadoop cluster, then you might create a Dataproc cluster on the GCP side. If that does not have any Hadoop jobs, it has some Oracle jobs, then you will create something else. Let's say a simple VM that you will create, right? And for pulling all these data, how many resources, how many VMs you want, how many other resources you might require. Depending upon that, you have to understand the requirement of your subnet. So let's say you want 4000 VMs will be enough. You can go with /20, right? That's what we have seen. So you can go with /20. You can expand. So don't worry if you go and create a subnet. You can also create another subnet in the same region. Okay, so there are some good practices that you go for the custom ones and do not use the auto or the default one, so that you get more freedom later point of time. Also you can create, you can expand your subnet. You cannot shrink the, okay, you cannot shrink the this particular address space. So let's say you have /20, you can always go for a bigger one. You can make it /16. But if you have a /16, you cannot go to /20. Okay, you cannot shrink it, your subnet. We'll see. I mean, why I'm not showing is I don't want to have too much of the theory part. But yeah, so that depends upon the need of your project, right? So you need to decide how many resources we might require in this entire project, and depending upon that, uh, but in most of the projects I have seen, just they go for /16 or /20. That should be enough. /20 is smaller, you can consider that as a smaller one, but /16 is an appropriate range that you can go for. Okay, then VPC include multiple data centers. VPC is global. VPC is global, I said, right? VPC is global. You have this one as a one subnet. One subnet means one region. This is another region. This is another region. But the VPC is the entire perimeter, right? So VPC is global. It can span across the data centers. VPC per project or per organization. VPC is not per, nor neither per project nor per organization. You can create multiple VPC in your project. Okay. Every application that needs hosting on GCP will have its own. No. It's not per application also. Not every application will be of its own VPCs. VPC is like, not sure. I mean, I give you a very layman understanding also, but VPC is like this, and this is your project. Okay, another VPC. Let me 1 second. Give me a minute. Okay, this is one VPC. This is another VPC. This is another VPC. VPC 1, VPC 2, VPC 3. Okay. Now, don't relate or don't directly relate with the actual physical location, because VPC is virtual. Okay, so if there is a data center in Mumbai versus London versus any US, Iowa, right? So don't relate directly like that. Okay, 1 second. So don't relate directly like that one. Okay, so this one can have multiple regions, right? So in Mumbai there is one, then in London one, right? Similarly, this also can have Mumbai region. subnet. This also can have this one like this, but they are all in the same project. Okay, and then within that subnet you create VMs or any other resource, not just VMs. You create your resources within that particular subnet, right? So if this all are there in same project, so far we have seen, right? So far we have seen just at the project level, but under the same project you can have different VPCs, not necessarily that they will serve uh, I mean one application you want to deploy and you have one VPC, then you another application you want another VPC. No, you can have multiple applications in the same VPC also. Okay, so typically you don't need to create so many VPC. That's not a good practice. Okay, I hope that is clear. Don't relate directly with the physical infrastructure of Google. Okay, this is but I mean just be with that. Okay, and when we'll see the different concept, network isolation and all, with diagrammatical representation it will be little bit more clear. Dia, I'm not sure, you mistyped a lot of things. Sorry, I'm not sure if you okay. Shiva, what about IP6? IP6 is also supported. Any reserved IPs in GCP. So IP6 does not have any kind of reservations like that, but IP6 is also supported. But for the simplicities, we'll be going with IP4 only. And 99% of their projects will still using IP4 only. So for everyone's simple understanding, I'll be using IP4 addresses. But the IP6 is also supported. You can go with IP6 also. Okay, so let's take 5 minutes of break, and then we'll jump onto the console. Dia, it's not how many. I mean, you keep on asking how many, but it's all depends on your need. You can create many. I mean, by default, there is a quota of 5 VPCs you can create in one project, not in organization. In one project, you can create 5, but you can always increase the quota as I shown you in introduction, right? So we can increase the quota, but again, creating so many VPCs will also be not a good practice. Okay, subnet, please explain one more time. So Shiva, I'll have to explain in this particular, the break that we have. Okay, I can't take the class entire class time, so Shiva, you have to adjust with your break then. So subnet is nothing but a subset of your network, right? It's a subset of your network or a subset of your VPC. So basically the VPC is entirely uh, across the globe, right? Under that, if you are creating this particular subnet, or I would say you guys hold on, just when we will go to the console, it will be clear. But conceptually, if you want to understand again, then VPC is like global. So let's say Mumbai, then I have London, then I have Iowa, right? Then we have, let's say, Chicago or anything. Now, this is about GCP physical infrastructure, right? Now, everybody is using these regions. What I can do is Harshal. This is Harshal. I can have my VPC and I can create a subnet just for Mumbai. Okay, this is for Mumbai. I can create a subnet in my VPC for London. I can create a subnet for Chicago. Okay, but this is entirely is nothing but my VPC. But under that, I have subset of my network. Okay, per region. Generally, subnets will be per region, one per region. Similarly, Shiva can also work in his project and he can also create in the subnet for Mumbai, maybe for Chicago. but not for London. He might be creating for Iowa, right? So this is what I mean by subnet means subset of your VPC. Okay, but don't relate directly with this one. Okay, so what happens is if I create one small VM in Mumbai, it will be physically created in this region. And if you create a small VM in the Mumbai in your subnet, this will also be created here physically on this particular data center. But they will not be able to talk to each other because they are in different project, even though not in project in the same project. If they are in the same project, but they are in different VPC. So don't go with where it is, just go with this one. Since if it is outside VPC, you have a safe perimeter around your resources. Shiva, that's a conceptual understanding of subnet and VPC. Okay, so how much time do I get? I get 1 minute. I'll be back, guys. Okay. Okay. So let's jump onto the console. Let me close this. This. That's also okay. Console.cloud.google.com. Let me log in. Okay. So let's create one project. So I'm creating a new project. You can work on the existing one as well. That's fine. Doesn't matter. And this is my free tier account. I'll not be able to choose any organization. That's okay. Create. So it's creating a new project. Okay, so it has created a new project. So if I go to this one, I should be able to see this particular project. So I'm selecting this particular project which I just created. Okay, and then let me go to VPC. If I search for VPC, I have VPC network. So basically you'll have to enable compute engine. Fine. So as we discussed, right, we'll be I don't need this. Okay. So we'll be seeing these things. Okay. So we'll see first of all that we'll check with every project do we get a default. So since we have created a new project, we should be able to see a new default VPC. So let me go to the VPC. So I landed up here. If you see here, 35 subnets has been created automatically, right? This default VPC is there. If I just collapse it, I have only one VPC over here, right? So that's a default VPC. And under that we have, so let me collapse that. So MTU that we'll see later. It's a very small thing, not really important much. But 35 is the subnet number of subnets that I have under this particular VPC. The mode is auto, even though it is a default one. It is because most of the things, most of the features for auto and default is same. Okay, that's why the mode is automatically created. Okay, IP addresses, if you see here there are no IP addresses, okay, associated with this one. That means VPC is a global resource, it does not have any address space, right? I told you here it does not have any IP address, but to have a IP address we need a subnet, that is a subset of your particular VPC, right? So if you see here, you have the GCP has created one subnet per region. Okay, that name is also default. And if you see here, there are 35 subnets created for 35 regions automatically. And if you see here, there is a range also given. So 128 10.128 10.132 slash 20 slash 20. That means each of these subnets has slash 20 as a limit. Okay, slash 20 means we have seen, right? I think 4096 IP addresses this particular range can generate. Okay. So this is automatically created. If you see here, four automatic firewall rules are also there. So if you go to firewalls, these are the four default four firewall rules that are those are created, and those are are also tagged to this particular VPC. Those firewall rules are also tagged automatically to this particular VPC, right? Now, I said, right, we can shrink. So let me show you. So let's say if I select any of them, right? If I go for, let's say, South America East, okay, and it's a slash 20, right? So I can edit this, or I can create an auto one and then I can edit that one also, but fine. What I mean by this is shrinking means, or shrinking means what? See, we have seen here, right? Going higher in the value is shrinking, right? Bigger to small, small to smallest. Going higher from 16 to 20, from 20 to 22, 24, 32, whatever, is it is shrinking, correct? So if I try to make it 21, so it says CIDR range should be a superset. That means it is not letting me shrink my network. So shrinking is not possible. Okay, expanding is possible. So let me write it down here. Okay, so if I make it slash 20 how it was earlier, if I make it 18, it is possible. If I make it 16, it is possible. If I make it 15, okay, let's try. 16 it is possible, but let's try with 15. I wanted to show you. So I got an error, right? Invalid field, this one cannot expand the CIDR range of an auto subnet beyond 16, right? So the maximum I can expand is up to 16. This is only for these things, auto and default, right? I said we can expand to 16 and we can expand to 16, but here you can expand to even bigger than 16 also. You can expand later point of time. If you have created with /20 and later you want to expand your network, then you can do that as well. Okay. Now overall, the discussion for all these things, that why we are creating a VPC, then we are creating a subnet, under that subnet we are creating small VMs, right? All these things are important because of the fact that, very important fact, I showed you, right? I said just im- keep this in mind, this particular point, that we are going to talk on the private line, right? That means we are going to only use the advantage of networking and all these things is use the private IP addresses and do not use external IP addresses. Okay. So external IP addresses are vulnerable again, right? Because those you are making it public, right? That's why for any internal communication, let's say your website is hosted on 10,000 VMs in the backend, they need to talk to each other, of course, right? So that is where, or let's say you have a cluster, a data proc cluster, that they need to exchange the data between. So all these data will be exchanged using the private IP addresses of each other. But private IP addresses, as we have seen earlier, those are not reachable directly, right? And that's why there are certain rules. If they are in the same VPC, then they are reachable. Okay. So, so if VMs are in the same VPC, then they can communicate using private IP. Okay, don't worry, we are going to see the demo, but just understand this thing is that we are not going to create any resources with public IP addresses now. By public IP addresses has two flaws. One is they are vulnerable because they are internet exposed. They are exposed to internet. So anyone can exploit that. They can do any malicious attacks on those VMs. Okay, because those are reachable via internet. Of course, you can have certain things like firewall rules and all those stuff. You can have some security around that as well, but it makes your VM still vulnerable to outside world. That's why it is always a best practice to have only private IP to your VM or any other resource, and let that private IP talk to a private IP of another one, another resource, if it is really allowed in your entire network that you are creating, right? So just understand this particular point. So, and that private address space is defined by this particular range that we are creating, right? So you cannot expand this beyond 16. 15 is not possible. Only from 20 to 16 you can go. But for custom ones, you can go. You can go to 16, 15, 10 also, 8 also, anything. Okay, so let's jump on to the VPC network again. And here, if you see here, I have an option to create a VPC. Once I click on create VPC, it will ask, if you see here, there is a mode. So do you want a custom mode or an automatic mode? That's where I was talking about the second one, right? The auto mode. This is now on the creation side, this will be very similar to, let me say my auto VPC. Okay. Description is fine. IP, if somebody had asked me about IPv6, so you can enable that as well. So it will support IPv6 also, but just for simplicity, we'll go with IPv4. Now, if you see here, I'm just selecting automatic. Once I created I've selected automatic, automatically all those entries, one for each region, automatically populated. Okay. So if I go with the automatic one, and also on the firewall rules, I can go with See, now here I wanted to talk about two types of firewall rules, but we are going to revisit this. But just understand there is no select box here. So these are called as implied ones. Okay. So firewall rules, implied implied ones. Okay. These are always applied to all networks. You don't have any control on this. Okay. What are these implied firewall rules? Deny all ingress. Ingress is nothing but ingress is inbound, egress is outbound. I'm telling you all this terminology, but later on we are going to revisit. So don't worry, just understand. Ingress is incoming traffic, egress is outgoing traffic. So it is denying all the incoming traffic and allowing all the outgoing traffic from any VM or any resource that you create, not just VM, any resource that you create in this particular VPC. These two rules are default. This will be applied to everyone. Okay. Other than that, if you want specific firewall rules also, you can choose from this one. Okay. So by default, they are giving ICMP. These are protocols and the ports. This is again basics. So 3389 TCP22 is SSH. You remember when we create a VM, we had an SSH. We clicked on SSH and we connected to the VM, right? So and we have also seen the putty. Putty is also using 22 port. ICMP is like ping. You remember, you might know about the command ping command, right? So ping works on ICMP protocol. So protocols and ports I'm not going to cover, but you can select. Okay, I want all of them, and then you can say routing is fine, just keep it regional for now. And MTU is basically the size of your packet, the maximum size of your packet. Or because the data, when it travels from one resource to another resource, or from one resource in the same VPC, or from one resource from one VPC to another resource in other VPC. So wherever that packet goes, it goes in a packet, right? So it goes in header, then we have data, then header has some characteristics, data has some data to be exchanged, right? So all that is nothing but your packet, and the packet size, the maximum packet size is 1460. That's what you can go for. And you have certain other options also. Last time I had seen was 1500 was the maximum size. Now if you see here, they have support for 8896 also. But this is the well being used by uh, majority of the companies. So we'll go with that as that only in your project. This is well tested and known thing. Okay. So let's create one. So we are creating one automatic VPC of automatic one. So here also I should be expecting 35 subnets getting created, one per region. Okay. So so this is getting created. Now one important point I wanted to show, I'll show you once this creation is complete. Meanwhile, let me take the questions. So with every new project we create, their default VPC gets created default VPC gets created automatically, Shabby. And if you want a certain control, let's say now I wanted certain control on firewall rules, let's say, right? So or dynamic routings, right? Static routing, dynamic routing, I want some control, then I can go for auto also. But in most of the cases, in actual enterprise level applications, you will see custom VPCs. Okay, let me refresh this and see here, 35 subnets have been created. Oh, come on. Sorry, my machine is acting weird. One second. So if you see here, 35 subnets have been created the same way as default had created, right? and I selected these firewall rules. That's why therefore firewall rules. Otherwise, I could have selected 0. It would have shown 0. But those implied ones would have been there for all of them, right? So this is how it is. Then if I click on this particular VPC, and if I edit this, well, this is one more thing I wanted to show you, that I can go from auto to custom. I can change the mode of my VPC from auto to custom, but this is the warning. Switching from auto subnet to a custom subnet is allows you to manually define the subnet prefix. What does it mean? I can select my own CIDR ranges. Okay, that the freedom I'll get with this one. But once you do that, I cannot convert a custom one into auto one. Okay, I cannot go from custom to auto. From auto to custom it is possible. Okay, so let's not do that. Instead we create a another custom VPC. Okay, maybe we can create right away and I'll show you. So let me create another one. The names I would put my custom VPC. That was my auto VPC. This is my custom VPC. Here is my custom. If you see here, it is asking me to create a subnet because it is now on me to create the subnets. Now, depending upon your application, right? So let's say for your project, this is the project in which I have a default VPC. I'm not going to use this. I have a custom VPC here. Okay, and I need to create a VM on which I'm going to serve the traffic only to India. So I want only I'm sure that my India customer base is only going to use this particular website, right? I mean, I don't care about the other regions, let's say, right? What I can do is I can create a subnet, because unless and until I have a subnet, I can't create a resource because subnet will have IP address, right? So I can create a subnet for one of the region in India, maybe Delhi or Mumbai. Those are the two supported regions that we have, right? And then under that I can create this particular VM, and then I can just expose that as a xyz.com, and it will be available to all the public. It doesn't mean that it is not accessible from US, or it doesn't mean that it is not accessible from London or Europe. It is still accessible. The only the fact that it will be served from this particular VM, which is in Mumbai or Delhi, depending upon wherever we create, right? So the why my point was basically, if you have such use case, you will only create a subnet for that particular region. Why do you need 35 subnets if you are not going to create any resources? Or maybe you, as we had seen in a very first understanding, that let's create one in Chicago, right? Because I'm going to create one instance in Chicago and one in London. So I'll create one more subnet. We can only create 3 subnets. Why do we need 35 subnets and reserve the IPs ranges for all of them, right? That's very, that's a very practical use case. And that's why custom is the best one you should go for, right? So that you have a freedom. Whenever you want, you can add a subnet. Whenever you want, you don't want, you can delete a subnet. Whenever you want, you can expand a subnet, and whenever you want you can even no, shrinking is not possible, but expansion not just limited to /16. You can expand it to any limit. I mean, um, uh, when you have a custom VPC and subnet. Okay, so let me say, let's give it a name. This name can be anything, but I'm giving the same name that where I'm going to create. So US Central 1, and this is, I'm just giving a name, and region, I'm selecting the same region, so that US Central 1. So I'm going to create a subnet with this name, for this region, right? Then I'm going to use IPv4, and I need to give an address space, so I can give /16 or whatever it is. Okay, so this address space that I have selected, it must be from that RFC 1918 address space range that has been defined. I think it is, did I give you on this one? Let me just check so that you can refer it later. Yeah, so these are the ranges. Okay, those are defined for the entire world. These needs to be used. So my IP address range should fall under at least one of them. I mean, no, not at least one of them. It should fall under one of them, right? So the range that we are using is one of these range, 10.1.0.0/16. It should not, I can't use here. See, if you see these ranges, I can't use 12 dot 10 dot something. It's not allowed, right? So that's what you need to make sure. So this is the one range I have selected, and let's say I'm just creating a new VIP subnet, right? And I want all, I'm creating a VPC, and under the same VPC I'm also specifying this one, the subnet also. So it will create one subnet, only one subnet, 4 firewall rules, and that's it. Let's create this one. Gateway is the gateway is the way this particular VPC will talk to other, this particular, sorry, the region, uh, it will talk to other one. So let's say out of this /20 represents 4096 IP addresses, correct? The first IP address will be used by the gateway. So gateway is nothing but like a, let's say, one IP address will be gone in your this architecture. One second, whether or not. So when this particular subnet needs to talk to this particular subnet, right? It needs one IP address as well. So one IP address here, one IP address here. Okay. So that's your gateway. Is the public external IP address associated with any cost? Yes, Shiva. That is also I'm going to show you, but that costing is higher. That's why we should be using private IP addresses. So if you see here, I have only created one subnet, and that range is over here. The gateway using the first IP address of that, and rest of them will be available for our resources if we create under this VPC. Okay. So now let's see one concept. Okay, this is how we create different types of VPC. Now let's put this particular concepts or these VPC into action when we create VMs. Okay, so for that I'll take one concept also, and then we will take up the demo also on that. Okay, so let me go to diagrams. Do I have here? I have diagrams backup. Yeah, network isolation. Just give me 1 minute. Yeah. So let's talk about network isolation. What is network isolation? Okay, so let me explain over here itself, and then we'll jump on to uh, the demo. Okay, so we are talking about the same project first of all. Okay, the same GCP project. Okay, so let's say your free tier account, right? It has one project, or I am being showing the VPCs, right? I have created one custom, one auto, and of course one default is already there. We are not going to use this. Okay, so just understand these two things. You can have multiple customs also, that's fine, but basically here the network is nothing but your VPC. Okay, VPC and network is the same thing. Okay, now on the infrastructure side. This is the infrastructure, right? And this is at your network side or the VPC side. So if you see here, let me draw it like this, then draw it like this, then draw it like this, and then draw it like this. Okay. So if you see here, we have 5 VPCs in the same project, right? VPC1, VPC2, VPC3, 4, 5, right? So these are different VPC. This is one VPC. This is another VPC. Okay. So what does this particular isolation rule says is if your VM, if your VM is in the same VPC, this is the same VPC, and it can talk to another VM in the same VPC, even though it belongs to a different region. So if a VM is in US East 1 and another VM is in Europe West 1, they can talk to each other on private line. All we are talking about the private line, right? Of course, we have seen external IP address is reachable, of course, it is internet exposed, right? That's why we are not going to use the external IP addresses. We are going to talk on the private. So are they able to communicate on the private IP? The answer is yes, provided that they are in the same VPC perimeter. So the region doesn't matter. The subnets doesn't matter if those VMs are part of the same VPC. Okay, we'll see this in action. Okay, now coming to the other part, right? If this is a VM, it is in VPC 3 and this is the VM in VPC 4. Can they talk to each other on the private line? The answer is no. Even they are created in the same region. This also in the same project. They are created in C is created in US East 1. D is also created in US East 1, US East 1. And they are also in the same project, but they are part of different VPC. So basically, to understand, VPC is like a perimeter for your resources. They cannot talk to the resources which are outside the perimeter. Okay, so simple understanding, that is called as network isolation. Is this point clear? So we'll see that in action now. So what I'm going to do is I'm going to create one VM in this one, another VM in this one, and then let them talk to each other. Will they be able to talk to each other? No, because they will be part of two different VPCs. Okay, so VM, let me create. Snigdha, when we get break, I already gave you the break at 8:13. Snigdha, I myself did not take. I was discussing with Shiva, but I gave you the break. The next break I'll give you at 9 or 9:15 or something. Okay. So create instance. Let's create one instance. Okay. So let's call it as VMA. Okay. Now let me just check. Where is my this particular one? Right. Here central one. Fine. And this your central one, this east one, fine. It has all of them, but the custom one only has central one, right? So we'll create for custom in central one. So first of all, as per our diagram, let's create this one in auto. So we'll use this particular network one as an auto network, right? So we will create two VMs in different regions. One is in US East one. That's fine. Region we can select anything. So VM hyphen A, it has to be small. So in auto, I can select anything. US East one, let's say. I'll take a very small one, F1 micro. the smallest one. Then that's it. In go to advanced, here you can select the networking. So go to the networks, and here if you see here network interfaces, you can select the VPC here. Okay, so go to this one and select. I have three VPCs, right? So I'm going to select auto network, right? And automatically the subnet it will pick based on this one, because we had given this particular region, right? So it will automatically take the US East one related subnet, because auto has subnets in all the regions, right? So it will take that particular subnet automatically. And I don't want the external IP addresses, so I'll say none. That's it. And I should create one. Then let's go back to our diagram. Then I'll create VMB in the same VPC but in another region. Okay. Meanwhile, we'll create. Let the first one be getting created. Meanwhile, we'll create another one, VM-B. Now this one I am going to create in US Central one. Okay. This is another. This is a different region from the first one, right? The type configuration I am selecting. I mean, we can select anything, but I'm just selecting the same one, the smallest one. Let's go to the advanced. Let's go to the networking. Let's go to default, and I'm going to create in the same VPC, auto VPC. Automatically, it will take the US Central one region. It will not show it here, but this subnet range, this belongs to this one. You see here, we have selected region as US Central one, right? What is the range? 128, sorry, 10.128, right? This is, it has automatically selected based on our selection of VM, US Central one. Okay, let's go back here. I don't want any external IP address again. Say none, done, and create. So now so far we have created these two VMs. Those are on the same VPC, but those are created in different region. I mean, for conceptual we have seen different, but we have created in a different region. We'll see here itself. We'll see. One is in US East one will be in US Central one. Okay, it can be anything. You Asia, Europe, anything you can create. Now typically they are in a different region, but they're in the same project, right? And they are in the same VPC also. So can they talk to each other? Let's see. But on the private IP, right? We don't have any. So I can copy the private IP from here, and I can go here. I am logging into VMA, and I'm trying to ping the IP address of private IP address of VMB. Okay, and it is able to communicate even though it is in a different region. So even though it is in a different region as per diagram, even though those are situated in different region, but they are part of the same VPC. That's why they are able to communicate on the private IP. Okay. So now let's create another VM. VMC. Let's create this in US Central one. Okay. Certain one, a small VM, and go to networking, expand it. Now I am not going to create in the same VPC. I am going to create in another VPC, a custom one this time. So this one has my given subnet range. It has taken, right? You see US Central one hyphen subnet. That was the name we had created the subnet with, right? And it has taken that range. And I'm going to create that without. external IP again, and let's say create. So now, if you understand what I conceptually told you, right? The region might be same, right? So the region might be same for, let's say, we have created a VMB and I have created a VMC over here in another network. So this is one C, let's say, right? So I have created a VMC here in the same region of that of B. If you see here, let's go back to the console. By this time it might have created. So if you see here, the regions and the zones are same for B and C, but those are created in different VPC. That means those are beyond their boundaries, right? They are beyond the boundaries of each other. So now let's see whether they are able to communicate. So I'm just copying the IP address of VMC, and I'm going to, now I don't need VMA. Let me go and log in into VMB, and then we'll see whether it is able to communicate with VMC from there. This is all to understand the network isolation that we get by putting all these parameters of VPC and subnets around the resources. Okay. Global dynamic routing. Okay. So if I put the IP address of VMC, even if it is in the same region, right? Typically, this particular VM has been created on the infrastructure perspective. If you see, those are on the same, those might be sitting on the same rack also, right, on the GCP side. But since they are belonging to different VPC, this is in created in a auto VPC, this has been created in a custom VPC. So VPC wise, those are separated. Will they be able to communicate on private? So we are not getting any response. That means they are not able to communicate with each other. Okay. So I have 100% packet loss. So it's not reaching from this one to this one because the VPC parameters are different, right? And these are able to talk to each other even though the regions are different. Why? Because those are sitting in the same VPC parameter. Okay. So that is all about the network isolation. So let's take a 5 minutes break. Before that, let me check the questions. Yeah, the global dynamic routing. Global dynamic routing is just the I showed you on the diagram, right? Where on this one, right? You need a route to know from this place to this place how to go. This is a route. From again, similarly, you need from this one to this one. If you want to communicate, maybe physically or maybe on a talk, you need some route so that you have a permission. But you have a permission because you are already an authorized person to live in this particular society or in VPC. But in order to talk to each other, they need certain way of communication or the channel of communication. That channel is nothing but your routing, and that is also getting created automatically with your, sorry, with your VPC. Okay. So global dynamic routing, it is basically to dynamically, I'll show you when it comes to load balancing. For now, just understand this much. Okay. Don't want to digress from the topics, Dia. Okay. So just hold on for that. Under one VPC, subnets can communicate to each other. Subnets don't communicate. Subnet is just to, it's a representation that you have these much address space associated with you. Subnet is not a it's a resource, but it is a virtual resource. It does not have its own IP address. It just holds the group together. Okay. So subnet can communicate with each other by default under one VPC. Yes, you can say, but don't say subnets can communicate. You can say resources under the different subnets can talk to each other or communicate with each other. Resources is the word you should be using. Subnets would be chargeable for reserving IP. No, These are all private IPs that we are using. When we create a VM and we say external IP address needed, right? And then we see a external IP address here. That external IP address gets charging. And if you can also we'll see that, okay? But yes, the external IP addresses are chargeable. So let's take 5 minutes of break, and then we'll see firewall routes and then external IP addresses, and then we'll see how to talk to these two together. Okay, VMB cannot talk to VMC, right? Because they are in different VPC. We can make them talk to each other. Okay, so let's take a break. Um, I'll be back in 2 minutes, then I'll be around. Okay, I'm back. Okay. So the next topic we are going to cover is firewall rules. Okay, I hope everyone is back. So Dia has a question. Subnets would be chargeable as we are reserving the IPs. No, we are not reserving any external or static IPs. These are all internal IPs, right? These are all private IPs. Those are not chargeable. Then custom versus default subnet modes makes no difference from cost point of view. So cost on the network side, right? So cost on the network side is not on the how many VPCs you create, how many subnets that you create. That does not involve the cost. Okay, the cost is involved on how much traffic is going out of your network, how much traffic is coming inside your network. Depending upon that, the charges for the network perspective are implied. Okay, and another one is on the IP addresses, which are external IP addresses that we are talking about. The external IP addresses are separately again chargeable, but since that is where we want to avoid that, and another advantage is security, right? So from the cost perspective, don't look at I'm creating multiple subnets will incur more cost. No, it's not like that. It's just the management that you are trying to do, right? But that does not mean that custom has no advantages. Custom has all, you get all the freedom of choosing the IP address range, right? If you want, if you at an organization level, you first choose what are the IP addresses that we are going to use for our resources. Based on that, you get freedom. When you choose for the custom one, you get that freedom to give that particular subnet cider range when you are creating the particular subnet under that custom VPC. With default, you unnecessarily create so many other subnets that you are not going to use, and then it will be very difficult for you to track them. So if you are, another point is, if you are going to use this particular range for this one, and under default you have already exhausted or used this particular range for this one, right? But in custom case, in custom VPC, you could have used this one for expanding the US central one, again one more subnet under the same region you could have created with that particular range, right? So depending upon your management, your how you want to manage, right, the custom gives you more freedom. Okay, cost point of view, yes, absolutely. There is no much difference that you will get, but don't relate the cost directly with creating type of, I mean, which type of VPC I create. That does not incur any cost, but the resources within that and the traffic which is coming inside and going outside will be charged. Okay, so now coming back to the topic, firewall rules, right? So firewall rules are nothing but like, as I shown you right on this particular diagram that we first described or discussed, right? These are nothing like a security guard of your VPC, right? So I can say, sorry, what happened? One second. I think I need to close. I need to open this. Give me 1 minute. Something happened. Okay, now I can see it. Okay, so firewall rules are nothing but security guards of your network. Okay, or you can say gatekeepers. They keep an eye, they keep an eye on, watch on any unethical or malicious or malicious activities, you understand, right? So hackers or kind of communities might try to exploit your website. They might want to hack your website, and then they want to, you know, maybe bring your cluster down, and then they want to bargain with you on this their requirements or whatever, right? So depending upon I mean you know, this particular firewall rules will help you to keep an eye or keep a watch on such type of malicious activities coming to your network. Basically the resources, right? This is not just one way, this is both ways. Okay, so you can also restrict your resources in your VPC to do certain things on the internet or something like that, right? So let's say I don't want my VM to communicate with internet. I can do something on the firewall rules. I can block the HTTP protocol on that particular resource, on that particular resource on my particular VPC that I have, right? So it can be both ways. Both ways means it can be ingress and egress, right? Ingress, which is inbound, and egress, that is nothing but outbound. Okay, so basically you have a control here, what can be done and what cannot be done. So you have that particular control using the firewall rules. Does the firewall rules does all the jobs? No, but firewall rules is like just primary check on your network, who what type of traffic is allowed and put on particular resource, and what type of traffic is not allowed or denied, should be denied. So there are some parameters for all of them. So 5 parameters of firewall rules. Okay, we are going to see that on the console also. One of them, first one is direction. Direction, as I said, right? Ingress and egress. Now I'm going to talk about, I mean, use ingress and egress as a terminology. Ingress is any traffic that is coming inside. I can either allow them or deny them. Depending upon firewall rules I select or I create, I can give an action whether, okay, this type of traffic should be, you, let's say, just for an example, right? You must have seen the signboards on the societies or the entrance of any apartments, right? On their boundary or on their compound walls, they have says no salesmen are allowed, right? Or no bachelors are allowed. This is how you know, most of the Indian uh, society premises, they do not allow, some of the societies do not allow bachelors to live in that, right? Or some of them do not allow salesmen to come inside, right? So automatically it is like a, you know, a watch that you are putting, that okay, these kind of people are not allowed in the society. That is nothing but ingress traffic, right? I would egress traffic is like, if that particular security guard feels that okay, this is not allowed outside the society, nobody can take any office uh, particular stuff or things from which belongs to the society, that or that a particular apartments, that cannot be taken out for their personal use outside the society, right? So that is not allowed. That means egress is also denied, right? So ingress in egress is nothing but the direction of that particular traffic. Okay, so the packets are coming in or packets are going out, that depends that defines the direction of that particular traffic, right? Then source and destination, you can also select to whom it is applying, right? So you can select the sources, so to whom it is applied. So if I say I will be creating like this. Okay, so this is a global notation, 0.0.0.0/0. What does this implies? This implies a apply to all. So I can say, or I can say 10.192.0.1/32. Only this particular IP address. So whoever is having this particular IP address, that only can communicate with my network, then I can do that as well. I can configure at that particular level also. Okay, so I can specify from which source I'm expecting. So if I'm making it open for all of them, so this particular rule that I'm going to create, any particular rule that I'm going to create will have all those 5 parameters. So any traffic, what does this say? What does this say? This says that any traffic, this applies to everyone, right? So any traffic coming from anywhere, then I want this firewall rule to be tested. If it is applicable, then only allow that particular packet to come inside the network, right? So that's how it is. Then we also have port and protocol. So port and protocol, or protocol and port, is nothing but the type of traffic. You are deciding type of traffic. So like we have seen, right? We have done the SSH right now. So SSH is nothing but it uses the TCP protocol on port 22. Okay. This one I am talking about. If you are not making sense, we have created a SSH. So what we are doing from this particular from our network, we are doing SSH or TCP port 22 connection to this particular VM. Okay, so that will be SSH connection from my laptop to that particular VM using TCP/22 is SSH. Then ICMP is one of the protocol that we try to communicate between this VM, right? This VM is trying to connect to this VM, another VM, VMB, using ping command, right? The ping command uses ICMP protocol. So depending upon the different protocol, let's say you are creating a website and you are broadcasting that as a website, and then I need an access, right? So you need to create a another protocol, the protocol and port, HTTP, right? And for that you can create HTTP works on TCP 80 or 8080, depending upon that. Right? So you, let's say you have somebody, let's say Dia, right? So Dia has a website and she wants everyone to use that using a browser, right? So she has to have a firewall rules with the action called as, I mean, allow, right? Allow action for any traffic for anyone. So she will put the source as this. So anybody from the internet can talk to this particular network on this particular port, on this particular protocol and port, that will be like HTTP call, right? And that will be ingress, and she will say action should be allow, it can be or denied also, right? So she will say allow. So who would be anybody will be defined from this one, and who will be coming to that particular network, that will be ingress for that particular network, Dia's network. And it will be an browser based HTTP traffic, right? So it will go as TCP 80 traffic, and the firewall rule says allow it. So it will allow to hit that particular website and it will show the response, right? And then priority. So priority is basically which rule to apply first, like precedences. So if I have hundreds of firewall rules, so in which order I want them to be applied on. So every packet that comes inside my network, that has to follow all the firewalls, right? Let's say I have 100 firewall rules, they all will be applied. So let's say this is the packet and this is the VPC, and I have created hundreds of them, right? 100 firewall rules, 100, and this is firewall rule 1. So the priority tells you that okay, this packet needs to be validated, okay, against each of them. Okay, so priority will decide, okay, firewall rules has the highest priority, then it will be applied first. So if firewall 1 allows it, doesn't mean that firewall rule 2 cannot deny it, right? Based on firewall rule 2, it may be that it is not allowed, then finally that packet will not be allowed, correct? So that's how this parameters will work. So let's see that in action. Let's say that will be better. So if I go to VPC and go to firewall rules, right? Or let me create one VPC. I'll show you on the creation. Okay. My custom VPC2. Let's create one custom one. Okay. Sorry, give me a minute. And let's create US central one, subnet one. Okay. This will be US central one, right? So, okay. Then I need to give some IP address range. Fine. Done. So I created one subnet. Let me create one more. The same thing we'll use for one of the demo as well. So let me create. So I'm creating another subnet in another region. So it is Europe Central 2. So let's select Europe Central 2 also. Okay, this is one more subnet. For that I need to give one more range. And these ranges should not be overlapping. Okay, that's a very important point that you need to take care, that the subnets that you create, they should not have any overlapping IP addresses, right? So they should be completely exclusive to each other so that there is no conflicting. Okay, so now talking about the firewall rules, right? So these two things, right, these are the implied ones. If you see here, so these are applicable to all. This applies to all. That means the range is 0.0.0.0/0. Okay, then all the protocols, any traffic, this is for any traffic, not for a specific type of traffic, right? It's not just for SSH, it's not just for the ping command ICMP, it's not just for the HTTP traffic, right? It applies to any traffic. And the type it says as ingress. So any traffic that is coming inside my network, this particular network, it denies. By default it denies, and it allows all the traffic that is going outside my this particular VPC. It will allow. Okay, allow whatever goes, but deny anything it comes inside. But if you see here, the priority is 65,535. Okay, so that talks about this one. Priority can be from 0 to 65,535. Okay, the the highest the value, the lowest is the precedence, right? The 0 has the highest precedence. The 0 is the most important one, right? So if you see here, this has, by default, these are implied ones, right? So these are applicable to all the VPCs that you create automatically. If you don't have any VPCs, if I don't select these, still these two will be applicable, right? So that is why when I select these, right, then if you see here, the priority is higher, is 534. So these will be applied first, these will be validated first, right? And that's where I can allow them, even though it says deny everything which is coming inside, but I can have allow. Okay, allow this, allow this, allow this, right? So since the priority is higher, it will be applicable, this will be applicable. Okay, if this allows, then this deny doesn't matter for this particular type. So these are also some pre-populated, we can select. For now I don't want to select this. Okay, I'll show you why. So by default it will, so what will happen is I am not selecting any of them. So by default my network will have only these two, right? So deny all in ingress traffic, right? So let's create that with, I'm not creating any other firewall rules. So by default, any traffic which is coming inside this particular network should be denied. That's what it says, right? So now let's wait for this one to complete, and then we'll create a VM inside this particular VPC. Okay, and then I'll show you how it is blocked. Till now, when we created a custom VPC and auto VPC, we selected all the four firewall rules, and they allowed us to do the SSH traffic. You remember? They have, let's say, if I open the custom VPC, the previous custom VPC that we had created. Give me 1 second. Again, my machine is slowing down. So yeah. So if I go in the previous VPC, okay, not the recent one, the previously we had created custom VPC. If you go to the firewall rules, okay, so it says allow SSH, and it has a priority higher than that deny all, right? It is 534. So it says allow the SSH traffic, allow the ICMP. If somebody is trying to do ICMP, that means somebody is trying to ping me, allow it. Somebody is trying to do SSH on me, allow it. So with this IP address, with this particular VPC, we created a VM, right? VM B or C, right? So that's why we were able to SSH into that, right? Now let's create another VM in the new VPC, the VPC2. Okay, in VPC2 we don't have any firewall rules. Okay, so meanwhile we get that form. Let me just make it double sure that we don't have any firewall rules on this VPC2. So by default SSH, ICMP, nothing is allowed. Okay, let's create one. Okay, let's create one VM here. Let's say VM in VPC2. Okay, fine. And what are the subnets do I have? US Central 1. So let me select US Central 1. I can only create the VMs if I have the subnet for that. I mean, I can create any resource in region. So, given that I have a subnet for that, right? Because the IP addresses will be decided from the subnet range. So I'm selecting US Central 1 because I have a subnet for that. I can create in this one also, but for now, US Central 1, F1 micro, and let's go to the advanced networking. Here I select the VPC2. Okay, because I'm going to create that in this particular VPC2. And do I want external IP addresses? Yeah, let's keep it. Okay, just we are not going to see 1 second. Where is that? Okay, so I'm keeping external and internal both. Let's say done. Okay, and that's it. Let's create this VM. Okay, so now I have an external IP also. So let's see, can I? So this is my project, right? If I open CMD in my laptop, if I ping this particular external IP address, is it reachable? No, it's timed out, right? So even though it's an external IP address, since I don't have any firewall rules, I'm not allowing anything. By default, the rule says deny any traffic coming in, deny all ingress, right? So ingress is denied automatically, right? So that's where even I cannot SSH into this one. Let's try to do SSH. It's trying to create an SSH connection. So basically what it's doing is it is trying to send TCP 20 traffic on TCP 22 port, but since it's denied, right? So deny all ingress. That's why we don't have option to connect to the SSH, even though we have an external IP address, right? So what we can do now, we can go to this VPC, open this VPC, and edit this VPC. Okay. Now once I edit this VPC, I go to firewall rules. By default, the implied ones will not be shown. Okay, implied ones are automatically applied on all of the VPCs. So let's create one firewall rule. Now let me call it as allow SSH ICMP. Okay, I'm going to allow SSH and ICMP traffic on this particular VPC. Okay, so it is on the same this network. Okay, on this network I'm going to do priority. Let's keep it 1000. Fine, 1000 is way higher than the implied one. Implied is on this priority, right? So 1000 will have more precedence. If 1000, this firewall rule is allowing it, then it is allowing it. If there is no firewall rules to allow anything, then by that automatically we have seen, right, the implied one was taking effect. So I say the direction is ingress. I'm expecting somebody to do SSH on this particular network, so I'm selecting ingress, right? Then what I want to do, I want to allow it, or I want to deny it. I want to allow the traffic. Now what is the target? So target is that VM, right? This particular VM. So do you want this firewall rule? See, firewall rule that we are creating is at the VPC level we are creating, right? But this firewall rule can be created at particular level also. So the firewall rule can be applied to any specific, sorry, any, what happened? Give me 1 second. Okay, yeah. So I can create that firewall rule on any specific resource, or I can create that for all resources in that VPC, or I can create for any specific service account also. Okay, so it's not a good practice to create at a resource level, right, for every VM. So I may have 25, 30, hundreds of VMs also in my project. I don't need, I would have to create firewall rules for all of them, right? So instead of that, what I can do is I can have something called as network tag. Okay, we'll see what is network tag. But it's like just let's say in let's say in a college event or any event, we have some volunteers, right? So somebody had asked me something about labels and network tags also earlier, right? So let's say there are group of people who are volunteers. So what do? We give them a volunteer t-shirt which says volunteer on the t-shirt itself, right? So that way, if we say all the volunteers gather at XYZ location, automatically that particular announcement is applicable to that particular set of people, right? Similarly, we can allow the firewall rules for a broader audience using the network tag. Okay, instead of doing that on a simple every resource one by one, we can have it on the using a network tag. Or for now, just to understand easily, we will apply this firewall rule on the all the resources, not just a specific VM or a specific resource, but we will select that for all the instances in the network. Okay, then we have specific network tags, or we have specific service account. But for these two, let's keep it for now and keep it aside for now, and let's select all instances in the network. So any instances that we have created, like this one, right? We have created in this particular VPC, that will be, this firewall rule will be applied and validated against. Okay. Then source IP source IP range, we are setting anywhere, from anywhere I can, I'm expecting the traffic from anywhere. Okay. Then what do I need to do? Do I want to allow all? No, I wanted SSH and ICMP only, right? So as per my name, whatever I have kept, so I'll say SSH. SSH works on port 22 of TCP, and ICMP goes as ICMP. Okay. Then that's it. Let's create this particular firewall rule. This firewall rule has been created in this particular VPC, the VPC2, right? Now let's try to do SSH. So now since the priority is 1000, and the firewall rule says allow from anywhere on SSH, right? And allow it. Then let's see whether it is allowing. Now let's try to ping also. So now the ping started working, right? And also in the background, if you see here, the ping, the SSH communication is also done, because ICMP is also done. So ping is working, SSH is done, allowed. That means because of that, SSH is also, I mean, the SSH session is also successful, right? So that's how this particular firewall rule we are able to apply. Okay. Now, if I want to do furthermore, but how much time do we have? 20 minutes. So that's fine. So let's keep this aside. If time permits at the end, I'll show you one more type of firewall rule. So uh, right now we have selected all the instances, right? So maybe we can, using the network tag, we can connect. Okay. But for that, we'll have to do certain things, like we have to install a web server on this and all those things. But so let's park that for time being, and at the end we will take if time permits. So the next topic I wanted to cover was routes. Now we have seen firewall rules, right? So let's say this guy, and there was a VM, right? Just now we have seen it was denied. Okay. Why it was denied? Because there was no firewall rule here. The firewall rule that was, this particular guard was known about, was knowing about, was deny everything earlier, right? That's where we added one firewall rule, and we told them that okay, SSH, if it is an SSH traffic, allow it. Okay. Then this particular guard or the firewall allowed us to do SSH session to this VM. Just now we have seen this right here. But does having a firewall rule, does only having a firewall rule in place completed this particular connection between my laptop and this VM? Okay, this VM? No, the answer is no. It's not just the firewall that allowed this, but in order to have this particular communication, I need to have something called as route. I need to know which route I need to reach out to that particular VM. Unless my traffic goes and reach out to that particular VM, that particular communication will no longer, I mean, it's not even possible, right? So that's where we have routes in place. So go to routes. Simply put, if I want to put it, the routes and the firewall rules. Okay. So the routes, sorry, the routes plus firewall rules go hand in hand. Okay. They go hand in hand. So this combination is important, not just the firewall rule. Okay, so even though I have a firewall rules, but the route is not there, then it will not be able to communicate with that particular VM or whatever resource that we create. Okay, so if you see here, 99% of your time, of the time that you work, these routes will automatically be managed by GCP for all your network. Whenever you create any VPC, if you see here, you have auto VPC, you have default VPC, you have custom VPC, you have custom VPC2, everything. These routes are automatically created. So whenever you create a subnet, automatically a route is automatically created by GCP on your behalf to reach out to that subnet. And from under that subnet, you know already that we have multiple other instances. So 99% of the time, this is automatically taken care. You don't need to touch any of them, right? But still, in case you need a certain person, a certain person, a very specific person or a VM. When I say person, I mean some resource, a very specific resource needs to talk to this particular VM. Then you can create a your static route, and under the static route you can specify which IP address of this particular VM. Only that will be able to communicate to this particular VM, right? But most of the projects that I worked upon, we do not use any static routes or anything. We just go by the dynamic routes, and these are all the automatic routes that are created. So the next hop goes to this particular network. So it tells you this particular route will be used for this particular network, and this will go to this particular particular subnet within that VPC. Okay, so that is pretty much about the routes. The dynamic routes we will see when we cover VPN. Okay, so just park it for now. Just understand route is the way of communication, the path of the communication, whereas firewall rule is the person or the idea, an entity which allows or denies if the traffic is coming in. But for traffic to come in or go out, you need a route. Okay, so that's all about the routes. Then the next one, something that we were talking about, the external IP addresses, right? External IP addresses. So there are some characteristics that we need to understand. Okay, so let's say you want to create a website. So of course you will need an external IP address. Unless it is an external IP address, you won't be able to communicate with the internet, right? External IP addresses communicates with internet. Okay, then that will be the IP address that people will be using. Not always the, I mean, not the IP addresses, but there'll be a DNS mapping, and then you will be getting a domain name like xyz.com, and then people will be hitting xyz.com like Amazon or Flipkart.com, right? So, but internally they have an external IP address which is getting invoked, and then that particular external IP address will be communicating with the underlying backend resources, maybe VMs or whatever it is, but you don't directly hit the VMs which are sitting inside, I mean, at the back end, right? So for having a website, right? So let's say external IP address can be of two types, right? So it can be ephemeral or static. Ephemeral means temporary. So if you have a VM, let's say this one, right? We have a VM. This is an external IP address, but this was an ephemeral one, right? So if I stop this VM and create another one, stop the VM and start this VM again, this external IP will be gone. This will give me another external IP address, right? Random external IP address. But since this external IP, let's say if I have a website which is being used by thousands of people, I can't keep on hopping to one IP address to another IP address, right? Because that xyz.com will no longer work, because external xyz.com was associated with one IP address, so a single IP address. That's where you need something static. That IP address no matter what you do with your VM, right? You stop that, you start it, so that IP address should not change. That's where you need a static IP address. So if you go here, IP addresses, you can reserve a static IP address. So you can reserve a static IP address, but just remember, charge, charges are implied on this. Charges are even higher. Higher charges can be implied if this IP address that you reserved is not in use. Okay, you have reserved it, but you are not using it. Then it will be charged even higher. Okay, so if how can I do that? So if you see here, reserve external static address. So I can go here. I can, let's say, I can create anything static. I can say static IP. This is just a name of that for that reservation, and then I can say it is. Do you see here attached to none? Right now by default it is attached to none. So it says static IP addresses not attached to an instance or a load balancer are billed at higher hourly rate. Okay, so I can just simply create this, and this is of the type static. It's not being used by, it's used by none, right? So right, and this is the IP address that now if I attach this particular IP address to a VM, then that VM's IP address will never change. This will remain the same, and then this will show in use by that VM, right? So that's about the static IP addresses. So this is generally being used by the load balancer or the VMs, but how for a use case when you have a web application. So how a typical web application will look like is you will not deploy your, you will deploy, but you will not expose your VMs directly. You will have VM1, VM2, VM3, VM4, VM5. Okay, you can have hundreds of them, doesn't matter. Then you have something called as LB, load balancer, and they all are connected to the load balancer, and then load balancer has an external IP address, and load balancer is exposing your website xyz.com, and then people is just hitting this particular xyz.com, right? And then load balancer will decide from where I need to give the response to this particular user. This particular user will go to VM1, this particular VM might go to VM2. This load balancer will have algorithm, and decision making will happen at this load balancer. We are going to see that in one of the session in load balancer. And this load balancer will have an external IP addresses associated. So we can keep it as a static one and attach to the load balancer. So that's how a typical web application architecture will look like. Okay, so that's a use case of, when it will be used. Okay, so now talking about external IP addresses, we have 10 minutes. Either we can discuss about the pricing, or we can discuss about the peering. Let's talk about pricing. Pricing is a small VPC. Peering will be a demo in itself. It will take minimum 20 minutes for me. So let's finish the pricing. Okay. So for pricing, I have one diagram. Let me take that diagram. Okay. So this I have taken from the Google documentations only. So what does it say? The first point. Okay. So it's a traffic type. and this is pricing. Okay, so any traffic, the first point, any traffic which is inbound for a network, no cost on this. Okay, so it is free of cost. So if you are bringing any ingress data inside your network on a resource, right, the ingress traffic will not be charged at all. Okay, so I'm talking about the traffic that is flowing in, not the data. Okay, so let's say if you are bringing any data, so for bringing any data from your on-premise, let's say, into your GCP, that will not be charged. But when you keep that data in some storage location, that storage location will charge you for that storing the data. But for bringing the data on the network, right, maybe you have some kind of connectivity which we are going to see further. So we have established a connectivity between on-premise and GCP. Okay. Now, for my GCP network perspective, it is an ingress traffic coming in, right? So GCP will not be charging you for bringing any traffic inside your network. Okay, that's what ingress has no charges in the GCP. Then rest of the ones we are talking about the egress ones. So now the traffic is going outside the GCP realm, right? In some other, I mean, not outside, always outside GCP. It can be outside your region, outside your zone, outside your particular VPC, right? Depending upon different categories, the egress charges are little different, right? So the first one second. Now, egress means leaving your region or zone or VPC, right? Depending upon, but it is outgoing one. It's a leaving traffic, right? So now, if the traffic is between the resources in the same zone, okay, if the resources are in same zone, okay, and they are communicating using private IP, then no charges. Again, no charges. Let me we already have a diagram, right? So let's talk about the on the diagram itself. If we have same, if we have some two, let's say two resources, let's say two VMs, they're talking to each other on internal IP address, but they are also sitting in the same zone, right? Then there is no charges involved here. Okay, similarly, if your resource is trying to send any traffic to Google product, right, like maps or drives or YouTube or any Google workspace or Google's suite, right, these charges are also there. I mean, for going traffic outside your particular resource is also not charged. Okay, then any traffic that is going outside and using to a different GCP service, okay, but it is in the same region. Okay, your another resource where you are sending the traffic is also in the same region, then for most of the cases, there are some exceptions. For most of the cases, there will be no charges. What are these exceptions? So exceptions, I'm just writing some exceptions. There are some services like Firestore, Memory Store. If you are not using these services, then your uh, egress traffic will be free of cost. Okay, now if you are using in the same region but between the zones that you are going, right? So if your traffic is going out between the zone in the same region, just like this, okay, in the same region but between the zone, then it will be charged. This is for these particular type of services, right? The one which are without exceptions, right? So these are the ones for which it will be charged for 0.001 $0.01 per GB. Okay, that is one more point. Then if you are doing egress, within the same zone, but you are using external IP address, right? You are still two resources are talking to each other within the same zone, but they are using their external IP address to communicate with each other. Then these charges will be per GB, it will be 1 cent, $0.01, right? And then if it is going outside the region now, if they are talking or the traffic is going out from one VM outside the region, but it is between US and Canada. Okay, this communication is still between US and Canada, then this will be charged at this particular rate, $0.01 per GB. But if that particular traffic is not going to Canada, it is going outside, let's say US to some other region, then it will be again depending upon which region it is going to. So region wise, it will be different. I mean, will be slightly different, not much, but these charges are, we can see it on the pricing page. I'll have to find it out, but if you're interested, I'll give you the actual link of that documentation. But yes, it will be slightly different and it keeps on varying. So that's why I have not included here. And so just in a nutshell, any traffic which is coming inside for a network, that will not be charged. But if anything that is going outside that particular resource, then it will be based on the category. It will be either charged or not charged or variable in charges. Okay. So that is all about the pricing. This is about the networking. Okay. Now, if you are creating a VM will have its own pricing. If you are storing a data on a cloud storage will have its own pricing. The pricing that we are discussing is only about the traffic coming in and the traffic going out. Okay. Clear? Any questions on these topics that we discussed? So let me take the questions. So is it possible to create one subnet with 10 series IP address? I mean /10, I think, right? And other subnet with 192 series. Okay, 10 series. Yes, you can create as long as it is. Let me. I have one more. I mean the same. I have somewhere RFC, right? We have. Let me put it. Let me put it at the bottom, okay? Because otherwise, these all diagrams and whatever I have written will go off. 1918. So these are the IP ranges. So as as long as you follow this particular range, one with 10, one with 192, doesn't matter. Yes, you can create. Shiva. Can you give an example? Egress traffic. Usually it will be reading from storage. So let's say egress is like for, let's say I am sending one traffic. Let's say you have a hybrid cloud or you have two projects. Okay. One project is having one VPC, another project has another VPC. There is a one VPC and there is another, sorry, one VM, or let me put it this way. This is your org. Okay. This is your company xyz.com. Under that, you have multiple projects. This is project 1. This is project 2. This has VPC 1. This has VPC 2. This has, under that we have a subnet, and under that we have a VM. Okay, so I'm directly creating a VM. VM2, VM1. They are still for the same org they are working, right? If this guy wants to send some reports or some data to some CSV file or some anything to this particular VM2, I want to push some data, right? For this, it will be an ingress traffic, but for this network, this is an egress traffic. So any traffic, any particular packets which are going outside this particular resource from this particular network, we have to see the charges for this particular category, and based on that category, it will be charged at this particular project. This will not be billed at this project because this is an ingress traffic coming in for this particular project. So, and at this particular project, it will not be billed at all because this is an ingress one for this. But for this one, it is a regress one.
This will be built for this from this project's billing account. Okay, so that's an example. For basically, you might have seen, right, one project, we need to send the data from one team to another, and they might be using, they have a dedicated project, even though they are working for the same company, right? So that's where uh, the charges will be in different. Or any response codes, communication, signal traffic between the resources. Sorry, Dia, let me read your question again. Can you give an example of egress traffic? Usually it will be reading from storage. No, not just storage. It may be that you are sending one data, a data from one VM to another VM, not even writing to any cloud storage or any other storage, just sending the data to one VM. Or maybe you are from one VM to, you are invoking the website which is hosted on VM2, right? It's again a traffic, right? You are sending some request. Okay, so to download patches, so download the patches will be taken care for patching, and anything you are not getting charged because you are using a managed service, right? These are all those managed. What do you say by manage? Everything, patching and everything is taken care by GCP. They do not charge you for all these. I mean, they do charge, but it's transparent. When you create a VM, it's automatically patching and all, everything they already give you the guarantee about, right? So that costing for that VM, the price that you pay for the VM, it's already factored in for this patching and all. You don't, download the patches and all. But yes, for your website, if you are having a web application and you are need to patch something for your web application, that is your responsibility, correct? It's not the resource that it's getting patched. Your website needs some patching. For that, yes, you can send those patches to all the VMs, and that will be like ingress egress traffic that will be considered against. That is a correct point, Ankush. If you are thinking from a web application patching perspective, a VM patching, no, VM patching will be taken care by GCP. They will not charge you separately for that. Any other questions, guys? I see I answered all the questions, I think. If I have missed any questions, then please post it. Tomorrow, I think, let me just check. I think we have not seen this demo. The first thing we'll cover this tomorrow, and then we'll further discuss about the hybrid connectivity. So it's good that we have it on the hold. So tomorrow's agenda will be to connect different VPCs to each other. Maybe now this VPC can be, now connectivity will be hybrid or GCP, right? So what are we going to do tomorrow is, this is one VPC, this is another VPC. This VPC can be, now this can be in GCP, this can be in AWS, this can be on-premise, and this we are having in GCP, right? So how a GCP VPC can talk to another GCP VPC, or how it can talk to other one, how it can talk to on-premise, we are all going to see that tomorrow with a lot of demos. So yeah, so I think if there are no more questions for today, I'm just removing this one, okay? So that it's not been discussed yet. So that's it. So if any questions, just put it now. Else, let's conclude for today. And just reminder for the feedback. Just feel the feedback, please. I think there was a feedback last session that I need to include more realistic examples. So that's where I started, you know, giving you an examples like how typically this load balancer external IPs will be used, right? How these network isolation will be in place. So how you can have within the same project, you can have further isolation of your networks or your resources, that even though it is in the same project, it will not be able to communicate even on the private IPs. Then how the firewall rules will take an effect, right? And at the same time, I tried making it simple by giving an example of an apartment, and simple that somebody from a non networking background should also be able to understand, okay, how the networking happens. So that's it, I think. That's it from my side. Thanks, Dia, for the kind feedback. Yes, and feel free to drop off now. If you have any questions, put the questions in chat. Else, just end the webinar and leave the webinar and feel the feedback for me. Yes, that's a sincere request, and thank you. Have a nice Saturday. Let's meet tomorrow. Tomorrow there will, I mean, we have to cover a lot of things. Tomorrow again will be the networking part itself, and networking will be for 3 sessions. Even next Saturday also will be on networking. Okay, have a nice day, mm, Mohammed Naid. Have a nice day, Niruddha. Okay, see you then. I'm just stopping the share, stopping my screen. Okay, guys. Are there any new questions? Anyone want to talk about anything? I can unmute. I'm there for 2-3 minutes more. Tomorrow, what all points we are going to cover, Dinanath? So we're going to cover the connectivity between the different networks, right? I told you it can be GCP to GCP connectivity. It can be a hybrid connectivity, meaning on-premise to GCP. But again, for on-premise, I can't create my on-premise. I don't have that much of bucks on my pocket, right? So for simplicity, we are going to create another GCP, and we are going to consider that different GCP project as my on-premise project, and we are going to connect that using different mechanism. We have VPN mechanism, we have VPC pairing, we have shared VPC. There are different mechanisms using which we can make the connectivity. There are different pros and cons of each of them. We are going to cover those things, Dinanath, tomorrow. So a very important one. Okay, any other questions? Any other question? Okay, if not, we can conclude for the day. Thank you, everyone. So I'm just ending the session. So thanks a lot. Really good session. Thank you, Dinanath. Okay, bye, guys. See you tomorrow.